Hi students, under algebra number theory, we are under unit 2, finite fields and polynomials. This is lecture number 8. So we are going to discuss the topic called as factor theorem, remainder theorem, and how to find GCD. I guess GCD expansion everyone knows, greatest common divisor. So we'll move on to the outline of the PPT. So first we'll just have a look at the factor and the remainder theorems. And next is problem on Monique polynomials. So Monique polynomials have been already discussed in my very first slide of a polynomial. Okay, so Monique polynomial is a polynomial where the leading coefficient is 1. Okay, so what is the leading coefficient? It's the highest degree term, right? So in a polynomial you will have an highest degree term, that is for example x power 5 or x power 6 or even x, whatever it is. Highest degree term, the coefficient of the highest degree term is 1, then we can call it as a Monique polynomial. Okay, so the coefficient is called the leading coefficient and the coefficient is 1, then we can call it as a Monique polynomial. So then we close this PPT with problems on GCD. So overview. The corollary of division algorithm branches into factor and remainder theorem. That's what's very important. So corollary is nothing but it is the extension of the theorem. So division algorithm, everyone knows it. So division algorithm, I've repeated several times in my third and fourth videos, lecture videos. So division algorithm is nothing but the dividend is equal to the divisor into the quotient plus the remainder. So from there only the corollary, the extension of the division algorithm has branched out as factor and remainder theorem. Factor theorem and remainder theorem. So here I have given you the statement of the remainder theorem and the factor theorem. So remainder theorem, let F be a field and an element A belongs to F and F of X belongs to capital F of X. Then F of A is the remainder when F of X is divided by X minus A. So I can say F of A is the remainder when F of X is divided by X minus A. That is the factor. That is the remainder theorem. Factor theorem. Let F be a field and A belongs to capital F and F of X belongs to capital F of X. Then A is the root of F of X. If and only if X minus A is a factor of F of X. That's why we write if 5 is the root, I told you X minus 5 is a factor. That is by factor theorem. So when I say A is the remainder, F of A is the remainder, then I can say X minus A was divided, has been used to divide F of X. So let's get into the next slide. So first, how to find the remainder? It's a very 2 marks problem, very small problem. So to ask, repeated asked in a university, Anna University. So what is the remainder when F of X is equal to x power 5 plus 2x cube plus x square plus 2x plus 3, which belongs to z5x divided by x minus 1. So f of x is equal to 5th degree polynomial when f of x divided by x minus 1. So I'm going to divide this. How to divide this? So it can be divided only by the remainder, right? F of a is the remainder, correct? So the remainder will be a, right? So a is 1. X minus 1 is equal to 0. So x is a is 1. So f of 1. So I take that f of 1 and substitute it here. So it becomes 1 plus 2 plus 1 plus 2 plus 3. So the answer will be 3 plus 2 is 5, 6, 7, 8 and 9. So your answer is 9. Under modulo 5, it is not perfectly divisible, but the remainder is 4. So the remainder is 4 in Z5. I will understand. So they're going to ask you for remainder. Okay. So what do you do? No need to go for division and all. You know by the theorem, it says that x minus 1 should be is a factor. From there you can get that 1 and substitute and see what is the remainder. Now second problem, what is the remainder when f of x is equal to 2x cube plus x square plus 2x plus 3 belongs to z5 of z5 is divided by x minus 2. Same thing. What is a factor here? What is a root? 2. So what I'm going to do, I'm going to substitute 2 over there in the polynomial. Before that, let me write what is z5. z5 is starting from 0 to 4. So directly I'll substitute 2 over there and see that what's the answer is 27. 27 is also not divisible by 5. So the remainder I'm getting is as 2. So the remainder is 2 in Z5. Able to understand? It's very simple problems, can be asked for 2 marks. So problems using monic polynomials. So you know what is a monic polynomial as I give you the introduction. So first you have to identify the leading coefficient, and leading coefficient, if it is 1, then we call it as a monic polynomial. So now f of x is equal to, see, they have given a polynomial as a product of 3 polynomials. One in a cubic power, one in another in a cubic power, and the other one is a linear equation. So they have given as a product of three polynomials, subpolynomials, which belongs to z7 of x. Then write f of x is a product of a unit and 3 polynomials, 3 unique monic polynomials. Given f of x is equal to, it is going to be, there's a correction, 2x square plus 1 into 5x cube plus 5x plus 3 and 4x minus 1 in z7 of x. So what is z7? Starting with 0 and ending at x. To write f of x as a product of 3 monic polynomials, we have to take out 2 from the first factor, 5 from the second factor, and 4 from the third factor. Why are they saying like this? Because those are the leading coefficients here. So the highest degree term is x square. The coefficient of the highest degree term is 2. So automatically I'll call the 2 as the leading coefficient. So here also the leading coefficient is 5. Here it is 4. So unless and until if the leading coefficients are 1, we cannot call those as your monic polynomials. So what should I do for it? So 2 from 2x square plus 1, 5 from 5x square plus 5x plus 3, and 4 from 4x minus 3. So 1. So which is congruent to 8 mod 7. Now 3 is congruent to 10 mod 7. Right? No need to 4 minus 3. So f of x is equal to the product of all these given. And now what do I do? From here I can take out 2 outside, because I need to have the coefficient of the leading polynomial and leading coefficient as 2. So take out 2. So 2, if I'm going to take out, it's going to be 4. So 2 times of x square plus 4. From here, what is the disturbance? 5. Take out 5. 5 into x square plus x plus 3. Sorry, x cube plus x plus 3. From here, 4 is the disturbance. Take out 4. 4 into x plus 1. So I could see that the leading coefficients of all these 3 brackets are 1. So automatically you start multiplying 4 into 5 into 2. So 4 into 5 will give you 20. 20 into 2 will give you 40. 40 into the product of the other 3 polynomials. So automatically you had arrived at a product of all the 3 polynomials where the leading coefficient is 1. So I can call them as a monic polynomial. So before that you got to divide this 40 for the mod 7. So mod 7 is going to be closest number will be 35 and the remainder is 5. So we are writing that. You don't need to look at this. Instead of this you can write a third factor, etc. So just try to understand. Okay, so when you're going to write, see whether the monic polynomial is the coefficient of that particular polynomial should be 1. Then only we can go ahead with that particular conclusion.